Analyzing quadratics in general form. So general form is this, y equals ax squared plus bx plus c, and this is factored form, which just means that your a is a factor that you've taken out of everything, and you've got x1 and x2 as your factors. It's important to remember too, when you have it like this, c is equal to your y-intercept. So x1 is one of your intercepts, x2 is another. Now to find your x value in your vertex, it's going to be halfway between these 2 points. So if you add them together and divide by 2, you should find your x value of your vertex. To find the y value, plug x into the equation. For this equation, we're going to first see that y-intercept is equal to 10 because it's this last value. Now, to find our vertex and everything else, we're going to factor this. So we're going to divide everything by negative 2.5. So we get y equals x squared. Oh, sorry. Negative 2.5 on the outside. X squared plus 3x minus 4. Now we want to find two numbers that add up to 3 and multiply to get negative 4. And our numbers are 4 and negative 1. And because a is 1, we can go right to our last step, x plus 4, x minus 1. Now if we solve for these, x equals negative 4 and x equals positive 1. So that's our x1 and our x2. So x1 equals negative 4, x2 equals 1. To solve for our x on our axis of symmetry or our vertex, we'd go negative 4 plus 1 divided by 2, which is negative 1.5. Negative 3 divided by 2 is negative 1.5. So our x value in the vertex is negative 3.5. To find our y value, we're going to plug it in. So y equals negative 2.5, negative 1.5 squared minus 7.5, negative 1.5 plus 10. Type it into your calculator and you get 15.625. So our vertex is negative 3.5, comma, 15.625. Sketch a graph of the following. So we have 4x squared plus 12x plus 5. When we're graphing, we should first check our discriminant to see if you can factor first. If you can factor, we'll do that. If not, we're going to have to do something else. So our discriminant is 12 squared minus 4 times 4 times 5, which is 64, which is a perfect square, so we know that we can factor. So we want to find two numbers that add up to 12 and multiply to get 20. Those numbers are 10 and 2. So we have y equals 4x squared plus 2x plus 10x plus 5, divide by 2x, divide by 5, y equals 2x, 2x plus 1, plus 5, 2x plus 1, so y is equal to 2x plus 1 and 2x plus 5. Our y-intercept is 5 from this. Our x-intercepts are negative 1 over 2 and also negative 5 over 2. So to find our vertex, x equals negative 1 over 2 plus negative 5 over 2 divided by 2, and you should get negative 1.5. So our x-intercept in our vertex is negative 1.5. To solve for our y, we substitute that in, so 4 times negative 1.5 squared plus 12 times negative 1.5 plus 5, and you should get negative 4. So this is our vertex, and we know our x-intercepts, and we know our y-intercept. So draw your graph. 1, 2, 3, 4, 5. So there's an x-intercept here, or a y-intercept at 5, at negative 1/2, and negative 5 over 2, which is the same as 3.5, or 2.5, sorry, here. And our vertex is at negative 1.5 and negative 4. So here's our graph. For the equation, y equals negative 2x squared plus 10x minus 14, check your discriminant. So 10 squared minus 4 times negative 2 times negative 14, and you get 12, which is not a perfect square, so we know that we can't factor it. So what we're going to have to do is complete the square like we did before. So y equals, we have to take a negative 2 out. Negative 2x minus 5x, leave a space, minus 14. Find your c value. Negative 5 divided by 2 squared, which is 25 over 4. So add 25 over 4, subtract 25 over 4. So our next step is y equals negative 2. Factor this polynomial and you get x minus 5 over 2 squared. And on the outside we have 2 times negative 25 over 4 minus 14. And if you simplify this, you get 3 over 2, which is negative 1.5. So y equals negative 2x minus 5 divided by 2 is 2.5 squared minus 1.5. So we know that our vertex is at 2.5 and negative 1.5, and it opens down because of this. So when we go to graph, draw your axis. Your vertex starts at 2.5 over and negative 1.5 down. So here's our vertex. And if we were to do a normal x squared, but it's 2x, so we go down 1, or over 1, down 2. Over 1, down 2, because it's a 2x squared. It's stretched by 2. So there's your graph. Graph of a quadratic equation passes through points 6 and negative 60, and the zeros of the function are at negative 4 and 2. Write the equation of the graph in general form. So we know that x1 is equal to negative 4, and x2 is equal to 2. So because we know both of our intercepts, we can plug it into our form y equals x minus x1 and x minus x2. So we have y equals a x plus 4 x minus 2. Now because we know it goes to the point negative 6 and 60, we can plug in negative 60 for y and 6 for x and solve for 8. So we have negative 60 equals a times 10 times 4, so negative 60 equals 40a, divide by 40, so negative 1.5 is equal to a. 60 divided by 40 is 3 over 2, which is 1.5. So now that we know our a, our x1, and our x2, our equation is y equals negative 1.5. Let me write this on the side. A equals y equals negative 1.5, x plus 4, x minus 2. Now to put it in general form, all we have to do is multiply it out and expand. So y equals negative 1.5 minus 2x plus 4x minus 8. So we have y equals negative 1.5, x squared plus 2x minus 8. And finally, y equals negative 1.5x squared minus 3x plus 12. When you distribute this out, and that's your form of general equation. For the last example, a doorway is a parabolic arch. The base of the doorway is 2 meters wide. At a point, okay, so let's draw this. So the door is 2 meters wide, so that's 2, so 0. At a point of 0.5 meters from one side, so 0.5, it reaches a height of 3 meters. So this point is 0.5, comma 3. Determine an equation that represents this parabolic arch. We know the vertex is going to be at 1 because it's halfway between 0 and 2. So x1 equals 0, x2, so these are our intercepts, will be at 2, and our point is 0.5 and 3. So y equals a, x plus 0, x minus 2. And we're going to substitute our points in, so 3 equals a, 0.5, and 0.5 minus 2. So 3 equals 3 times 0.5 times negative 1.5, which is negative 0.75a, divided by 0.75 negative on both sides, and negative 4 equals a. So that's our equation for our a. Y equals negative 4 x and x minus 2. If we expand this out, we have negative 4 times x squared minus 2x. So y equals negative 4x squared plus 8x. And that is our general form. Part B asks us if an item that is 3.5 meters high would fit through the doorway. So we want to find our vertex right there. So we know it's x equals 0 plus 2 divided by 2, which is 1. So our x value is 1. Plug this into our equation. Y equals negative 4 times 1 minus 2. Y equals negative 4 times negative 1, so it's 4. So our vertex is 1, comma 4, and because our y value we know is 4, 3.5 is going to be here, so yes. 3.5 meter tall item will fit.